Hello students, in this video we will be seeing solutions for previous year NEET question paper. So, we will be focusing on the topic called ray optics. So, before going inside the questions, we will just see the statistical analysis about the previous year question papers. So, if you see the particular topic called ray optics has several subtopics. So, namely reflection of light, refraction of light through glass slab, total internal reflection, refraction of light at spherical surfaces by lenses, combination of thin lenses in contact, refraction and dispersion of light through prism, some natural phenomena due to sunlight, human eye and its defects, microscope and astronomical telescopes. So, these are all the different subtopics in which questions were coming from this particular unit called ray optics. And if you have a look, the majority of questions were coming from these two topics, especially reflection of light through a glass slab and refraction and dispersion of light through prism. So, about 17% of questions were coming from these two topics, and about 19% of questions were coming from refraction of light at spherical surfaces and by lenses. And next, if you see, 15% of questions were coming from total internal reflection, and 12% of questions were coming from combination of thin lenses in contact. Okay. So, this was the majority of questions were coming from all these particular topics, and from other topics also questions were coming, but they were of least importance. So, this was the scenario for the past 33 years. But if you have a look at the last 8 years, if you see again the majority of questions were coming from refraction and dispersion of light through the prism. Around 24% of questions were coming from that, and if you see 14% of questions were coming from these two particular topics called reflection of light and some refraction of light at spherical surfaces and by lenses. So, majority of questions were coming from these two topics, and also from microscope and astronomical telescope around 10% of questions were coming. So, this was the scenario for the past 8 years. So, the majority of questions were coming from these four topics: reflection of light, refraction of light at spherical surfaces and by lenses, refraction and dispersion of light through prism, microscope and astronomical telescopes. Okay, this was the scenario for the past 8 years. So, we will try to solve all the sample problems from all these different subtopics, and we will try to give more importance for these specific topics like reflection of light, refraction of light and dispersion of light and microscope and astronomical telescopes. So, let us now see the first question. An object is placed on the principal axis of a concave mirror at a distance of 1.5 f, where f is the focal length. The image will be at. Okay. So, you want to find out where the image will be, and they have given us 4 options. So, here we are going to make use of this mirror formula: 1 by v plus 1 by u is equal to 1 by f. Okay. So, you are going to consider the sign convention, where here they are given the u value as u is equal to minus of 1.5 f. So, which you can write it as minus 3 by 2 f. So, 1 by v minus 1 by 3 f by 2 is equal to 1 by minus of 1 by f. So, if you just rearrange these terms, you will be getting 1 by v is equal to minus 1 by f plus 2 by 3 f. Okay. So, it is a simple mathematics, you are just going to solve it. 1 by v is equal to minus 3 plus 2 by 3 f, or v is equal to minus 3 f. Okay. So, the image will be formed at minus 3 f, v is equal to minus 3 f. So, the correct answer is option number B. So, it is a very simple problem, just we are making use of this mirror formula. Okay. Let us now move on to the next question. An object is placed at a distance of 40 centimeter from concave mirror of focal length 15 centimeter. If the object is displaced through a distance of 20 centimeter towards the mirror, the displacement of the image will be. Okay, so here you are taking a concave mirror and you are having an object which is around 40 centimeters from the concave mirror. Okay, so it is around 40 centimeters and the f value is 15 centimeter. They have given you the focal length as 15 centimeter. So here you are going to make use of the same mirror formula and you are going to find out at what distance displacement of the image will take place. Okay, so here if you see, the mirror formula is 1 by v plus 1 by u is equal to 1 by f, or 1 by v is equal to 1 by f minus 1 by u. So here they have given you the value of f as 15 and the value of u as 40. Okay, so you are going to write it as 1 by minus 15 minus 1 by minus 40. So if you solve this, you will be getting it as minus 1 by 24, or v is equal to minus 24 centimeter. So here the negative sign indicates the image is formed in the front of the mirror. Now according to the mirror formula, 1 by v dash is equal to 1 by f minus 1 by u dash. Okay, so it will be 1 by minus 15 minus 1 by minus 20. So if you solve this, you will be getting the v dash value as minus 60 centimeters. Okay, so here again the negative sign indicates the image is formed in the front of the mirror. Okay, so what we have done is, first we have taken the distance as 40 centimeter and you find out the v value. Now they are saying that the object is displaced through a distance of 20 centimeters. So you are finding out v dash by keeping u dash as 20 centimeter and you are getting the v dash as minus 60 centimeter. So in both the cases, negative sign indicates that the image is formed in front of the mirror. Now the displacement is given by v minus v dash. Okay, so it is minus 24 plus 60, so which is equal to 36 centimeters. So it is around 36 centimeters away from the mirror. So the correct answer is option number B, 36 centimeters away from the mirror. Okay, let us now move on to the next question. A beam of light from a source L is incident normally on a plane mirror fixed at certain distance x from the source. The beam is reflected back as a spot on a scale placed just above the source L. When the mirror is rotated through a small angle theta, the spot of the light is found to move through a distance y on the scale. The angle theta is given by. So here, when a plane mirror is rotated through an angle theta, the reflected ray may turn through an angle of 2 theta. Okay, so you are having the plane mirror over here like this, and you are having the source over here, and this is the light spot. Okay, so you are having it like this and you will be having it like this. Here 2 theta and this is x and this is y. So here you are rotating it into theta. So from the figure it is clear that tan 2 theta, which you can approximately take it as 2 theta, is equal to y by x. Okay, so theta will be y by 2x. So the correct answer is option number D. The angle theta is equal to y by 2x. So here, when a plane mirror is rotated through an angle theta, the reflected ray turns through an angle of 2 theta. That is what we are found out, and the theta value is y by 2x. Okay, let us now move on to the next question. For a transparent medium, relative permeability and permittivity mu r and epsilon naught r are 1 and 1.44 respectively. the velocity of light in the medium will be. Okay. So, here the refractive index of the transparent medium is given by mu is equal to C by V, or you know that C by V will be equal to root of mu r epsilon naught r. Okay. So, V will be equal to C by root of mu r epsilon naught r. So, it is V is equal to, the velocity is equal to 3 into 10 power 8 divided by root of, here the mu r value is 1 and the epsilon naught r is 1.44. So, 1 into 1.44. So, if you solve this, you will be getting V is equal to 3 into 10 power 8 divided by 1.2, or it is V is equal to 2.5 into 10 power 8 meter per second. So, the velocity of light in the medium will be 2.5 into 10 power 8 meter per second. Okay. Let us now move on to the next question. An air bubble in a glass slab with refractive index 1.5 near normal incidence is 5 centimeter deep when viewed from one surface and 3 centimeter deep when viewed from the opposite face. The thickness of the slab is. Okay. So, here the refractive index is given by real depth by apparent depth. Okay. So, T be the real thickness of the slab. So, the apparent thickness will be 3 plus 5, okay, because from one surface it is 3 centimeter and the other one is 5, it is 5 centimeter deep. So, the apparent thickness, apparent thickness will be 3 plus 5, which is equal to 8 centimeter. So, mu is equal to T by 8. So, T will be is equal to 1.5 into 8, or T will be equal to 12 centimeters. So, the thickness will be around 12 centimeters. So, the correct answer is option number D. Okay. Just we are making use of the refractive index formula, where it is the ratio of the real depth and apparent depth, and then you are finding out the apparent thickness. From that you are substituting it in the formula for the refractive index. So, it is T by 8. So, you can easily find out the thickness of the slab, which is around 12 centimeters. Okay. Let us now go to the next question. A small coin is resting on the bottom of a beaker filled with liquid. A ray of light from the coin travels up to the surface. How fast is the light traveling in the liquid? So, here they are given you the values of this is 3 centimeters and here it is 4 centimeters. So, you can just mark it as A, B and C. Okay. So, this is the normal, you can put it as N, N dash, and this is IC and this one is IC. Okay. So, from the figure we can find out AC is equal to 5 centimeters. Of course, we are making use of this Pythagoras formula and you are finding out AC is equal to 5 centimeters. And also after refraction the light may pass parallel to the liquid surface. So, the angle between BAC, this angle is equal to angle between ACN, which is equal to IC. Okay. So, you are taking sine of angle BAC is equal to sine of IC is equal to 3 by 5, because we know this is 3 and this is 5, this one is 5. So, sine of IC will be 3 by 5, but we know that sine IC is equal to mu r by mu d. So, mu d by mu r is equal to P r by V d. So, sine IC is 3 by 5. So, it will be 3 by 5 is equal to mu a by mu l. Okay. So, here V the V is the liquid velocity. So, it is V liquid by 3 into 10 power 8, which is equal to 3 by 5. So, the V liquid will be 9 by 5 into 10 power 8, or the velocity in the liquid will be equal to 1.8 into 10 power 8 meter per second. So, the correct answer is option number D, 1.8 into 10 power 8 meter per second. Okay, let us now move on to the next question. The frequency of a light wave in a material is 2 into 10 power 14 hertz and the wavelength is 5000 Armstrong. The refractive index of the material will be. So, here the frequency of light does not change with the change in medium. So, mu is equal to V1 by V2. So, which is equal to n lambda 1 by n lambda 2. So, where V1 is equal to n lambda 1, which is equal to 3 into 10 power 8, or mu is equal to 3 into 10 power 8 by 2 into 10 power 14 into 5000 Armstrong. That is what they have given you, the lambda value. You are substituting that, and if you solve this, you will be getting 3 into 10 power 8 by 10 power 8. So, which is equal to 3. So, the correct answer is the refractive index of the material will be 3, option number B. Okay. So, here you are taking the frequency of the light which does not change with the change in medium. So, mu is equal to V1 by V2, which is equal to n lambda 1 by n lambda 2. So, V1 equal to n lambda 1, and you are trying to find out mu. So, n lambda 1 is 3 into 10 power 8. So, you are substituting that, and here the frequency they are given is 2 into 10 power 14. We are substituting, and the wavelength is 5000 Armstrong. So, if you substitute, you will be getting the value as the refractive index will be around 3. So, the correct answer is option number B. Okay. Let us now move on to the next question. If the critical angle for total internal reflection from a medium to vacuum is 45 degree, then the velocity of light in the medium is. So, here they are given you sin C is equal to 1 by mu. Okay. So, sin 45 degree is equal to 1 by mu, or 1 by root 2 is equal to 1 by mu. So, mu will be equal to root of 2. So, the velocity of light in medium is given by V is equal to C by mu, or V is equal to 3 into 10 power 8 by root 2 meter per second. So, the correct answer is option number C, 3 by root 2 into 10 power 8 meter per second. Okay, it is a direct substitution of the formula where you are making use of this sin C equal to 1 by mu, and finally you are getting the velocity value as 3 into 10 power 8 by root 2. Okay. Let us now move on to the next question. If total internal reflection, when the angle of incidence is equal to the critical angle of the pair of media in contact, what will be the angle of refraction? So, we all know how total internal reflection takes place. So, the three major conditions you would have noticed, like you take two mediums, air and water. Okay. So, you are having three different conditions. Okay. So, initially what happens is the incident light angle of incidence is smaller than the critical angle. So, here it is I is lesser than the critical angle. You will be having refraction. Okay. When I is greater than the critical angle, you will be having I is greater than the critical angle, you will be having total internal reflection. But here what they are saying is when the angle of incidence is equivalent to the critical angle. So, when both are equal, I is equal to C, the angle of refraction will be 90 degrees. Okay. So, here in this case the angle of refraction will be 90 degrees. So, the correct answer is option number B. So if you remember, when you are studying about total internal reflection, you would have studied about the 3 different cases, okay, where a light is passing from one medium to another medium. 3 different cases occurs, like when the angle of incidence is lesser than the critical angle, what happens is refraction takes place, and when the angle of incidence is greater than the critical angle, total internal reflection takes place, and when the angle of incidence is equivalent to the critical angle, the angle of refraction will be 90 degrees. So here the correct answer is option number B. Okay, let us now move on to the next question. Which of the following is not due to total internal reflection? Working of an optical fiber, difference between apparent and real depth of a pond, mirage on hot summer days, brilliance of diamond. So of course we know that working of optical fiber is based on total internal reflection only. So it cannot be, as per the question, this cannot be a correct option. And if you see the apparent depth of the pond, it appears to be less than the real depth only because of due to the refraction of light. Okay, it's not based on the concept of total internal reflection. Okay, so the apparent depth of the pond appears to be less than the real depth only due to the principle of refraction of light, and it is not based on the total internal reflection. Whereas in the case of brilliance of diamond, formation of mirage on hot summer days and optical fiber working, all are based on the concept of total internal reflection. Okay, so all these three points are wrong statement, and all these 3 are due to total reflection. The only thing which is not due to total internal reflection is difference between apparent and real depth of a pond. So the correct answer is option number B, because this is based on the concept of refraction. Okay, let us now move on to the next question. A ray of light traveling in a transparent medium of refractive index mu falls on a surface separating the medium from air at an angle of incidence of 45 degree. For which of the following value of mu the ray can undergo total internal reflection? Okay, so here for total internal reflection to occur, we know that the angle of incidence should be greater than the angle of critical angle. Okay, so sin I should be greater than sin IC, and sin IC is 1 by mu. So sin I should be greater than 1 by mu, or mu is equal to 1 by sin I. Okay, so mu is greater than 1 by sin I. So here they are giving you the angle of incidence as 45 degree. So you will be having mu should be greater than square root of 2. Okay, so mu should be greater than square root of 2, because 1 by sin 45 degrees 1 by root 2, so you will be getting it as root 2. So here if you see, the mu value should be greater than square root of root 2, or mu should be greater than 1.44. So for which of the following value of mu the ray can undergo total internal reflection is, correct answer is option number C, because only option number C is having a higher value than 1.44. Other 3 options are having a lesser value of 1.44. So the correct answer is option number C. Okay, let us now move on with the next question. The power of a biconvex lens is 10 diopter and the radius of curvature of each surface is 10 centimeter. Then the refractive index of the material of the lens is. So here they have given you the power of the biconvex lens as 10 diopter. Okay, so we know that 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. So power is in diopter, f in meters is equal to 10 diopter. Okay, so you will be having it as 10 equal to mu minus 1 into 1 by 0.1 plus 1 by 0.1. So if you solve this, you will be getting it as mu minus 1 is equal to 1 by 2 or mu is equal to 3 by 2. So the correct answer is the refractive index of the material is 3 by 2, option number A. A plano convex lens of unknown material and unknown focal length is given. With the help of a sperometer, we can measure the either the refractive index of the material, focal length of the lens, radius of curvature of the curved surface, aperture of the lens. So first of all, you should know what is a sperometer is. Here you can see the image of a sperometer, which will be having a circular scale and a screw head, and it has a central leg and 3 different legs on either sides, and you are having a scale here. So usually a sperometer is an instrument which is used to measure precisely the radius of curvature of either a sphere or a curved surface. So generally the working principle of sperometer is based on the micrometer screw. So you will be placing the 3 legs on the surface of the glass surface on which you want to measure. So these 3 legs will be placed on the surface, and with the help of this micrometer screw, you will be able to measure a small thickness of flat materials such as glass, or it is also used for measuring the radius of curvature of the spherical surfaces. So if you see the options here, option number C is the correct one. It is used to find out the radius of curvature of the curved surface. Okay, so a sperometer is generally used to find out the radius of curvature of the spherical surface. Okay, so let us now move on to the next question. A equiconvex lens has power P. It is cut into 2 symmetrical halves by a plane containing the principal axis. The power of one part will be. So here, when a equiconvex lens is cut symmetrically along the principal axis, the 2 parts formed will have an equal focal length. Okay, since it's an equiconvex lens, so when you are cutting it at the center into 2 parts, both will be having an equal focal length. So since they are having an equal focal length, the power seems to be the same. Okay, so the power of one part will be equal to the power of the other part. So the correct answer is option number A. Okay, so when the lens is being cut into 2 halves along the principal axis, both the parts will be having an equal focal length. So since they are having an equal focal length, the power of the 2 parts will also be remaining the same. So one part will be P, means the other part will also be P. Okay, so the correct answer is option number A. Okay, let us now see the next question. A double convex lens has focal length 25 centimeter. The radius of curvature of one of the surfaces is double of the other. Find the radii of the refractive index of the material of the lens is 1.5. Okay, so they are asking us to find out the radii of the material if the refractive index is 1.5. So here they have given you the focal length of the convex lens as 1 by f is equal to mu minus 1, or which is equal to 1 by r1 minus 1 by r2. So here they have given you the r1 is equal to 2 r2 and mu is equal to 1.5, because they have given the radius of curvature of one of the surfaces is double the other. So r1 is equal to 2 r2 and mu is equal to 1.5, and focal length they have given us 25 centimeters. Okay, they have given it in the question itself. So just you are going to substitute here 1 by 25 is equal to 1.5 minus 1 is equal to 1 by 2 r2 minus 1 by minus r2. Okay, so if you solve this, you will be getting it as 1 by 25 into 0.5, which is equal to 3 by 2 r2, or r2 will be 25 into 3 divided by 4. So which is equal to r2 will be 18.75 centimeters, and r1 will be 2 r2. So it is equal to r1 equal to 37.75 37.5 centimeters. So the correct answer is option number D, 18.75 and 37.5 centimeters. Okay, just you are making use of the formula 1 by f is equal to mu minus 1 equal to 1 by r1 minus 1 by r2. Okay, so you are just substituting and you are finding out the radius of curvature. First one is 18.75 and easily you can find out the r1 value, which is 37.5. Okay, the next question is, two similar thin equiconvex lenses of focal length f each are kept coaxially in contact with each other such that the focal length of the combination is f1. When the space between the two lenses is filled with glycerin, which has the same refractive index mu is equal to 1.5 as that of glass, then the equivalent focal length is f2. The ratio of f1 and f2 will be. Okay, so here first thing is you have to find out when the two convex lenses kept in contact, the focal length of combination will be 1 by f1 is equal to 2 by f convex. Okay, so which is equal to 2 by f. So this is when both the lenses are kept in contact, the focal length combination will be 2 by f. Now when the space between the lenses is filled with glycerin, you will be getting f2. 1 by f2 will be 2 by f convex. So that is the convex lens focal length plus 1 by f concave. So this is due to the glycerin. Okay, so you will be having 1 by f2 as this one. So first what we have to find out is first we have to find out what is 1 by f is. So here 1 by f is given by f convex is given by mu g minus 1 into 1 by r1 minus 1 by r2. Okay, so 1 by f is equal to 1 by r. So now you are having glycerin in between, so you will be able to find out what is 1 by f concave. So which is equal to mu glycerin minus 1 into 1 by r1 minus 1 by r2. Okay, so here the mu glycerin same refractive index only, 1.5 minus 1 into minus 2 by r. So if you solve this, you will be getting it as minus 1 by r. Okay, so we have got 1 by f as 1 by r and 1 by f concave as minus 2 by r. Okay, so you are going to just substitute it here over here. So you will be having 1 by f1 is equal to 2 by r. So this is 1 by f1 because 1 by f is 1 by r. So you are substituting it here and you are getting 1 by f1 as 2 by r, and similarly 1 by f2 is equal to 2 by r because 1 by f is 1 by r here. So you are substituting here minus here 1 by f concave is minus 1 by r. So you will be getting it as 1 by r. So you will be getting this as 1 by r. So 1 by f2 is 1 by r. Now f1 you are going to put f1 by f2. So which is equal to r by 2 because here f1 is r by 2 and f2 is 1 by r. So into 1 by r. So the ratio f1 by f2 will be equal to 1 by 2, or you can say the ratio as 1:2. So the correct answer is option number D. The ratio of f1 and f2 will be 1 by 2. So it's a very simple problem only. You are just making use of the formula of 1 by f is equal to 2 by f convex because when in the cases two convex lenses are combined, and in the second case you are having a glycerin in between. So you will be have to find out the focal length of the glycerin, so which is 1 by f concave. So you are just substituting and you are finding out the ratios to be 1:2. Okay, so let us now move on to the next question. two identical glass mu g is equal to 3 by 2 equiconvex lenses of focal length f each are kept in contact. The space between the two lenses is filled with water, mu w is equal to 4 by 3. The focal length of the combination is. So, here the focal length of the combination is given by 1 by f combination is given by 1 by f convex plus 1 by f concave plus 1 by f convex. Okay. So, because you are having two different identical glasses, equiconvex lenses, you are placing it, and in between you are having water. So, that is why this is 1 by f concave. So, we know that by lens make a formula 1 by f convex is equal to mu g minus 1. So, which is equal to 1 by into 1 by r1 by r2. Okay. So, mu g minus 1 into 1 by r1 minus 1 by r2. So, here they have given you the mu g value as 3 by 2. So, it will be 3 by 2 minus 1 into 2 by r. Okay, because 1 by r1 is 1 by r, and the other term will be minus of 1 by r. So, it will become 2 by r. Okay. Now, if you solve this, you will be getting the value of 1 by f is equal to 1 by r. So, this was the same scenario like the previous problem. There we are using glycerin, but here you are using water. Okay, that is the only difference. So, the next thing is you have to find out what is 1 by f concave. So, it is 1 by f concave is equal to mu w minus 1 into 1 by r1 minus 1 by r2. Okay. So, here they have given you the value of mu w as 4 by 3. So, you are going to substitute that 4 by 3 minus 1 into this will be minus of 2 by r. Okay, because minus 1 by r minus 1 by r. So, it will become minus of 2 by r. Okay. So, if you solve this, you will be getting this as 1 by f concave is equal to minus 2 by 3 r. Okay. Now, you will find out the total combination, which is equal to 2 by r minus 2 by r. Okay, sorry, it is 3 by r. Okay, because you will be having 1 by r over here. This is 1 by r and this is 1 by r. So, if you add that, you will be getting 2 by r. So, the overall f combination focal length of combination will be, if you solve this, you will be getting it as 3f by 4. Okay. So, the correct answer is option number A. So, the focal length of combination will be 3f by 4. Okay. Let us now move on to the next question. A planar convex lens fits exactly into a planar concave lens. Their plane surfaces are parallel to each other. If lenses are made of different materials of refractive indexes mu 1 and mu 2, and r is the radius of curvature of the curved surface of the lenses, then the focal length of combination is. Okay. So, here they want us to find out what is the focal length of combination of these lenses. So, here the focal length of first lens is given by f1 by f1 is equal to mu minus 1 into 1 by infinity minus 1 by minus r. Okay. So, like different materials it are made, and it is one refractive index will be infinity, sorry, one radius of curvature will be infinity. So, if you solve this, you will be getting it as mu 1, this is mu 1 minus 1 by r. Okay, because 1 by infinity will be 0, so that term will become 0. Now you are going to find out the focal length of the second lens. Okay, so the focal length of combination of the second lens will be like focal length of the second lens will be similar formula, mu 2 minus 1 into 1 by minus r minus 1 by infinity. So which is again equal to mu 2 minus 1 by minus r. Okay, so now the combination will be 1 by f, the focal length of combination will be 1 by f equal to 1 by f1 plus f2. So here mu 1 minus 1 by r minus mu 2 minus 1 by r. So if you solve this, this is actually 1 by f is equal to. So if you solve this, you will be getting f value as r by mu 1 minus mu 2. Okay. So the focal length of combination will be r by mu 1 minus mu 2. So the correct answer is option number C. So this is also a similar kind of the problem, making use of this lens maker formula. 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. So you are just making use of it and you are substituting and you are finding out the focal length of combination, which is equal to r by mu 1 minus mu 2. Okay, let us now move on to the next question. A concave mirror of focal length f1 is placed at a distance of d from a convex lens of focal length f2. A beam of light coming from infinity and falling on this convex lens concave mirror combination returns to infinity. The distance d must equal to. Okay. So you are having it like this and you are having the mirror like this. Okay, and you are having a lens over here. Okay, and the light is falling on this like this and it is passing through this. Okay, so it will be coming like this. So this is f2 and this is f1. So this will be 2f1 and this will be f2. Okay, so what happens is when light from infinity falls on a convex lens, it is converged at a distance equal to the focal length of the lens. So now here you can see, as the light traces the same path to infinity, the image of the converged light must be formed at the same point after reflection from the concave mirror. Hence we can conclude that the image formed by the lens is at the center of curvature of the concave mirror. Okay, so the image formed is at the center of curvature of the concave mirror. So which implies the distance will be d is equal to f2 plus 2f1. Okay, so the correct answer is 2f1 plus f2, option number C. Okay, so generally what happens is when a light from infinity falls on a convex lens, it is converged at a distance equal to the focal length of the lens. So since here there are traces of the same path, light is having the traces of the same path to infinity, the image is converged light must be formed on the same point after reflection. So from the concave mirror. So we can conclude that the image formed by the lens is at the center of curvature of the concave mirror. Okay, so the correct answer is 2f1 plus f2. Okay, let us now move on to the next question. A ray is incident at an angle of incidence I on one surface of a small angle prism with angle of prism A and emerges normally from the opposite surface. If the refractive index of the material of the prism is mu, then the angle of incidence is nearly equal to. Okay. So, here what happens is you are having E is equal to 0 and R2 will be also equivalent to 0. Okay. So, angle of the prism will be equal to R1 and I is very small. So, mu will be equal to I by R1. So, which is equal to I is equal to mu R1 or I is equal to mu A. Okay. So, the angle of incidence is equal to mu into A. So, the correct answer is option number B. Okay. So, here they are saying that the angle is very small angle with an angle of prism as A and emerges normally on the opposite surface. Okay. So, R2 will be 0 and E will be 0. So, A will be equal to R1, the angle of prism will be equal to R1 and the refractive index is the ratio of the angle of incidence to the angle of refraction. So, it is I by R1, I is equal to mu R1 and already we know what is R1 is, which is equal to A. So, angle of incidence will be equivalent to mu A. It is a very simple problem. Let us now see the next problem. The refractive index of the material of a prism is root 2 and the angle of the prism is 30 degree. One of the two reflecting surfaces of the prism is made a mirror inwards by silver coating. A beam of monochromatic light entering the prism from the other face will retrace its path after reflection from the silver surface if its angle of incidence on the prism is. So, here the ray will retrace its paths from the mirror if it falls normal to the surface of the mirror. Okay. So, you will be having it like this and you are having this prism over here. So, you will be having A, B and C. So, here it is passing like this and you will be having a refraction and this is around 30 degrees. Okay. And here also it is 30 degrees, the angle of the prism is 30 degrees. So, angle of refraction is also 30 degrees. So, here what happens is the ray will retrace its paths from the mirror if it falls normal to the surface of the mirror. Okay. So, if it is falling normal to the surface of the mirror, it will retrace its path. So, angle AOP will be equivalent to 60 degrees and angle of refraction will be 30 degrees. So, making use of the Snell's formula, mu is equal to sin I by sin R or sin I is equal to mu into sin R. So, which is equal to root 2 because they are given the refractive index as root 2 into angle of refraction is 30 degrees. So, sin 30 degree. So, when you solve this, you will be getting it as 1 by root 2 or I is equal to sin inverse of 1 by root 2 which is equal to 45 degree because sin 45 degree is 1 by root 2. So, the angle of incidence will be 45 degree. So, here what happens is a beam of monochromatic light entering the prism from the other face will retrace its path when the angle of incidence is 45 degree. So, the correct answer is option number B. So, it is a standard question which have been asked continuously for 3 different years. Okay. So, in 3 different years this question was repeatedly asked. Okay. Not continuously, repeatedly it was asked in 3 different years. So, it is a very important question. You are just making use of the Snell's law and you are finding out what is the angle of incidence. Okay. Let us now move on to the next question. A thin prism having refractive angle 10 degrees is made of glass of refractive index 1.42. This prism is combined with another thin prism of glass refractive index 1.7 the combination produces dispersion without deviation. The refracting angle of the second prism should be. So here the condition for no deviation is given by A dash is equal to mu minus 1 by mu dash minus 1. So it is A dash by A is equal to mu minus 1 by mu dash minus 1. So A into mu minus 1 is equal to A dash mu dash minus 1. So here they have given you the refracting angle as 10 degrees and the refractive index is 1.42 minus 1 equal to A dash into the refractive index is 1.7 minus 1. So if you solve this, you will be getting the A dash values as 6 degree. Okay. So the refractive angle of the second prism should be 6 degree. So the correct answer is option number A. Okay. Let us now move on to the next question. Pick the wrong answer in context with rainbow. An observer can see a rainbow when it is front towards the sun, and a rainbow is combined effect of dispersion, refraction, reflection of sunlight, and when the light ray undergoes two internal reflections in a water drop, a secondary rainbow is formed. The order of colors is reversed in the secondary rainbow. So here the correct answer is rainbow cannot be observed when an observer faces towards the sun. Okay. So the correct answer is option number A. An observer can see a rainbow when it is front of the sun. So this is a wrong answer because you cannot see a rainbow when you are facing towards the sun, as rainbow is a combined effect of dispersion, refraction and reflection of sunlight. So it is a combined effect of dispersion and reflection of the sunlight. So an observer cannot see a rainbow facing towards the sun. So this statement is wrong. Here they are given that an observer can see a rainbow when he is in front of the sun, which is a wrong statement. Okay, let us now move on to the next question. A person can see clearly objects only when they lie between 50 centimeter and 400 centimeter from his eyes. In order to increase the maximum distance of distinct vision to infinity, the type and power of the correcting lenses the person has to use will be. Okay. So here the person is able to see object in infinity. The image should be formed at 400 centimeters. The image has to be formed at 400 centimeters. So U is infinity and V is minus 400 centimeters, or it is minus 4 meters. By making use of this lens formula, 1 by F is equal to 1 by V minus 1 by U. You can find out 1 by minus 4F minus 1 by infinity, or F is equal to 4 minus 4 meters. So here the focal length is negative, so we should make use of a concave mirror. Okay, so sorry, concave lens. So the power will be P is equal to 1 by F, so which is equal to minus 0.25 D. So P is minus 0.25 diopters. Okay. So the correct answer is since the focal length is in negative, it should be a concave lens and the power is minus 0.25 diopter. So the correct answer is option number C. Okay. Let us now move on to the next question. An astronomical telescope has objective and an eyepiece of focal length 40 centimeter and 4 centimeter respectively. To view an object 200 centimeter away from the objective, the lenses must be separated by a distance. So here they are given you the f0 value as 40 centimeter and fe value as 4 centimeter. So, for objective 1 by V naught minus 1 by U naught is equal to 1 by F naught. So, 1 by V naught minus 1 by 200 equal to 1 by its minus 200 by 40. So, if you solve this, you can easily find out what is the value of V naught. So, 1 by V naught is equal to 1 by 40 minus 1 by 200. So, if you solve this, you will be getting the V naught value as 50 centimeter. So, for a normal adjustment, L is equal to V naught plus Fe. So, which is equal to 50 plus 4. Okay. So, L, the lens has to be separated by a distance of 54 centimeters. Okay. So, the correct answer is option number B. So, we are making use of the lens formula and you are finding out what is the V naught value, and for a normal adjustment the distance must be separated. You have to add the V naught with the Fe value and you will be getting the value as 54 centimeters. So, the correct answer is option number B. Okay. Let us now move on to the next question. In an astronomical telescope in normal adjustment, a straight black line of length L is drawn on inside part of objective lens. The eyepiece forms real image of this line. The length of this image is I. The magnification of the telescope is. Okay. So, here the magnification of the telescope is generally given by M is equal to F naught by Fe. Okay. So, for a convex lens, M will be equal to Fe by Fe plus U which is equal to minus I by O. So, the object being line objective of an objective, U will be equal to F naught plus Fe and O will be equivalent to L. Okay. So, it will be Fe by Fe minus F naught plus Fe, which is equal to minus I by L, because O is L, you are substituting it here, and you will be getting it as minus Fe by F naught, which is equal to minus I by L, or M will be equal to L by I. Okay. So, the magnification of the telescope will be L by I. So, the correct answer is option number A. Okay. I think this video would have been useful for you to recall some of the problems from the particular topic called ray optics. So, as I was saying you in the previous slides, in the initial slides, try to give more importance to topics like combination of thin lenses in contact and reflection of light and reflection of light at spherical surfaces by the lenses, and refraction and dispersion of light through a prism, because majority of questions were coming from these particular subtopics. Okay. So, I wish you all a good luck for your exam, and thank you for watching this video.